Good afternoon.
Good afternoon.
How are you? Fine?
Yes.
Okay, today we are going to make our midterm exam review for mathematics. Are you ready?
Yes.
Okay. Starting with question number 1. The question is indicate whether the statements are true or false. Hassan, the first one.
In a triangle, the four sides are
Where did you read triangle?
in a rectangle.
Yes.
Four sides are equal. False.
This is false. Each two opposite sides are equal. Dana.
The opposite of 3 over 7 is minus 3 over 7. True.
This is true because the opposite of the positive is negative and the number stays as it is. Ala. This is true. Selena.
X minus 2 into x plus 2 equals x plus 2 squared. False.
What does x minus 2 into x plus 2 equal?
X squared minus 4.
This is difference of 2 squared, so this is false. Yes, Badia?
The right triangle, the median is equal to half hypotenuse.
True. Muhammad.
1 over A over B equal A over
What do we call 1 over a over b? What do we call compound fraction? So is it true or false?
false.
This is false. Because if we write 1 over 1, we multiply far, far. What will be the answer? Near, near. If we multiply b over a. Ali?
In a parallelogram, any two consecutive sides are equal. False. In a parallelogram, any two opposite sides are equal.
Yes, Dana?
A over 4 minus B over 4 is equal to A minus B over 4. True.
What do we call a over b minus b over, a over 4 minus b over 4?
Like fraction.
Like fractions, so this is true. We add or subtract the numerators and the denominator is the same as the first and the second. Ala. True. Badia.
If A and B are two non-zero numbers, then minus A over minus B equal minus A over B. False.
What does minus a over minus b equal?
Equal minus A over B.
Minus a over minus b is equal to?
A over B.
Yes, because the minus and the minus cancels each other, so this is false. Question number 2, we should construct a square MNPQ whose diagonal is equal to 4 centimeter. What are the properties of a diagonal in a square? Yes, Ali.
The diagonal square bisect each other.
First, they bisect each other, they are perpendicular, and they are equal. How can we draw, Selena, the square starting from the diagonals?
We draw diagonal MP. We find its midpoint. We draw a right angle. And then
At the midpoint,
add the midpoint.
how do we draw a right angle? Of measure what? The line will be. How do we draw the next one?
We take its midpoint.
Its midpoint,
The other line bisecting.
bisecting the first one. So the steps are, the two diagonals are perpendicular and they bisect each other. We draw, so in a square, the two diagonals will be equal, so MP is equal to NQ, and NQ will be 4 centimeter. We draw MP and we take its midpoint. Because they are perpendicular and bisect each other, we draw it using a set square, we get a square. Question number 3, calculate and reduce. Dana, if you look at A, the given, what do we call A?
Compound.
This is a compound fraction. First, we start with the line in the middle. If we look at the numerator, what do you have in the numerator?
1 over 4 plus 2.
What are these?
Unlike fraction.
What are we doing here? Which operation?
Addition.
Addition of unlike fractions. What should we do?
Or
We change them into like. The denominator will be
4.
4. Yes.
4 divided by 4 1.
Yes.
4 divided
1 times 1. We multiply it with the numerator. 1 times 1
1.
is 1. Plus. Yes.
4 divided by 1, 4. 4 times 2 is 8.
Is 8. Now we go to the denominator. In the denominator, we also have a compound fraction. We start with the unlike fractions. Denominator,
2.
yes.
2 divided by 1, 2. 2 times 1, 2.
2 plus
Plus 2 divided by 2, 1. 1 times 3 is 3.
is 3. Now for the numerator, 1 plus 8,
9.
9 over 4 over 2 plus 3,
5.
5 over 2. Okay, now we work where? In the denominator. How do we multiply?
Near, far, far.
Far with far, near with near. 2 times 2,
4.
4. 1 times 5.
5.
Now we have compound fraction. How do we multiply?
Far, near.
Yes, multiply. 9 times 5,
45.
4 times 4
16.
is 16. Yes, Badia, the second one. B equals 2 over 3 times 7 over 4 over 5 over 6. What do we have in the numerator, Badia? Which operation do we have? In multiplication, do we look for like or unlike? How do we multiply? Numerator times numerator over denominator times, okay. So we write 2, okay, over, okay. Now, what do we do in the numerator? Do we have any simplify in the numerator?
No. Yes, we have.
Between 2 and, okay, by 2, by 2, okay. 1 times 7, 3 times 2, over 5 over 6. What do we call this, Badia? How do we calculate a compound fraction? We multiply far with far, near with near. So the answer is? No, we don't get now the answer. We write 7. Yes.
Over 4, 6 times 5.
Do we have any simplify?
Yes.
6 and 6 over?
1.
We reduce by 6. By 6. 7 times 1. 1 times 5 is 5. So the answer is 7 over 5. Please pay attention. When we multiply, we don't write directly the answer. We multiply numerator by numerator, denominator by denominator. We see if we can reduce before we multiply, okay? Question number 4, Ala, read it please. What do we mean by develop and reduce? We should get rid of the parentheses. Start with the first one, Ala, please. So a minus 3 will be multiplied by 2. Yes, Ala. Yes. Minus 6. Minus 4a. Yes. Plus 6a. Now, after we multiply, what should we do? Similar terms together. Yes. First, 2a minus 4a. 2a minus 4a. Minus 2a plus 6a. 4a. So these are similar terms. We make them together. Minus 6 plus 1 is minus 5. Now b. Look at b, Dana. 2x plus 3, all of it squared. What's this? The first remarkable identity, which is
a plus b, all of it squared.
Equals
4x squared.
It is equal to 4x squared
Plus 12x.
plus 9. Yes. Now C, Selena. 3y minus half into 3y plus half. What's this?
This is the last remarkable identity.
Difference between two squares, which is equal to
9y
9y
squared
squared minus 1 over 4, which is a squared minus b squared. Now D, 3b minus 2, all of it squared, Hassan. So D equal 3b minus 2.
second
remarkable identity. The answer is
9b squared
9b squared
minus 12b
minus 12b
plus 4.
plus 4. Now the last one, Ali.
x plus 2 into x minus 2 minus 2x plus 3 into square.
Okay, the first two, x plus 2 into x minus 2, remarkable identity. The answer is
x squared minus 4
x squared minus 4.
minus
We keep the parentheses. Remarkable identity.
First we multiply the first term.
Yes, the answer is
4x squared
yes,
plus 12x
plus 12x
plus 9
plus 9.
equal to parentheses
Yes.
equal x squared minus 4
X squared minus 4.
minus 4x squared
Now we multiply the second parenthesis with a minus. Yes.
minus 4x squared minus 12x
Yes.
minus 9.
Okay, do we have similar terms?
Yes.
X squared minus 4x squared
Minus 3x squared.
minus 3x squared minus 12x. Do we have another x?
No.
So it is minus 12x minus 4 minus 9
Minus 13.
minus 13. Now f equals 3 plus 2a minus 3 all of it squared plus 2 into 3a plus 1. Yes, Selena.
Become 2a minus 3 all squared is a remarkable identity.
We start.
3 plus
Yes.
parenthesis 4a squared
Yes.
minus 12a plus 9
Okay.
plus 6a
We multiply the second with 2
plus
plus 2. Okay, continue.
3 plus 4a squared
Yes.
minus 12a
Yes.
plus 9
Yes.
plus 6a plus 2.
Okay, now similar terms together. What are the similar terms?
4a squared
4a squared is alone.
minus 6a
Minus 12a plus 6a is minus 6a. Plus 3 plus 9,
plus 12
12. Plus 2,
14.
plus 14. Question number 5. Hassan, solve. Solving, we should get the value of x. We have 4x minus 3 equal 5.
Okay,
4x equal
5 plus 3.
5 plus 3. All the x's on a side, all the numbers on another side. Yes, Hassan.
4x equal 8.
Equals to 8.
X equal
Now this is a simple equation, okay? Yes, x equal
8 over 4.
8 over 4, then x equal
2.
2. 8 over 4 is 2. Now Dana, 7y equal minus 4.
Y equal
This is simple, okay? We solve it directly. Y equal
minus 4 over 7.
minus 4 over 7. Yes, Ali, 2x over 5 is equal to 4.
We make a cross multiplication.
First, 4 over.
1.
So here what do we do? Cross multiplication, okay? Yes, 2x times 1,
2x
it is 2x.
equal 20.
We write equal at the middle. 4 times 5 is 20. 2x equal 20, then x equal, this is a simple equation, okay? X equal,
20 over 2.
yes.
Equal, x equal 10.
So x is equal to 10. Now, Badia, 4a minus 2a plus 3 equals 6a minus 7.
4a.
We should get rid of the parentheses. We multiply it with a minus. Start, Badia.
4a
Yes.
minus 2a
Okay.
minus 3
Equal.
equals 6a minus 7.
Now, all the a's to the first side, Badia. We write,
Equal 4a
yes,
minus
2a.
2a
Bring the 6a to the other side. It becomes,
plus.
it is plus. So minus 6a equal. On the second side, we have minus 7. It stays minus 7. If we bring minus 3, it will become, yes, plus 3. Now 4a minus 2a.
4a minus 2a minus 2a
2a minus 6a.
minus 4a
Now minus 4a is equal to minus 7 plus 3.
minus 7 plus 3 minus 5
Minus.
minus 4.
Okay. Now it becomes a simple equation. A equal to
8 equal minus 8
minus 4 over
minus
minus.
4 over minus 3.
Okay, so A equal to minus cancels minus 4 over 4 is 1. Question number 6. We have an expression A of x, 3x plus 2 into 4x minus 3 minus 9x squared plus 4. First, we should expand, reduce, and order this equation. To expand, what should we do? Yes, Selena. The first two parentheses are multiplied together. 12x squared
minus 9x
minus 9x
plus 8x
plus 8x.
minus 6
Yes.
minus 9x squared
Okay. Plus 4. Equal. Similar terms together.
12x squared minus 9x squared 3x squared
Okay, 3x squared minus 9x plus 8x
minus x
minus x
minus 2
minus 2, because minus 6 plus 4 is minus 2. Now, after we expand, we should factorize A of x. What do we take to factorize? The expanded or the basic one? We take the basic one to factorize, okay? So A of x is equal to. Now, if we look at A of x, the first two parentheses are finished, right?
yes
Look at the next part of the equation, of the expression. We have minus 9x squared plus 4. What do we have here? How many terms do we have? Two terms. So it's similar to the third remarkable identity. Is it the same?
no
How can we make it the same?
take minus
We take a minus common. So we write, yes, Ala? Okay.
4x
Yes.
minus
We take a minus common.
9x squared minus 4.
Yes. Now 9x squared minus 4 is the remarkable identity. So we write the first 3x plus 2. Yes, make the remarkable identity, Ala.
Minus 3x minus
This is a squared minus b squared, which is equal to a minus b.
into a
Yes. So 3x minus 2 into 3x plus 2. Yes, Ala. Now what do we have? What do we have as a common? 3x plus 2, big parenthesis,
4x minus
remains 4x minus 3, 3x minus 2. Yes. Now we work in the big parenthesis. 4x minus 3, 3x plus 2. Yes. Yes. 4x minus 3x is x. Minus 3 plus 2 is minus 1. So this is the factorized expression. Now we want to calculate a of minus half and a of 0. To calculate a numerical expression, what do we take? The expanded. So we take this one to calculate a numerical expression. Okay, we use the expanded expression. A of minus half, Muhammad, is equal to, we substitute x by minus half. Yes.
3 into minus half
All of it.
all squared
Yes.
minus into minus half
Okay.
minus 2.
Now, 3 minus half all of it squared. The answer is minus squared is cancelled because negative to the power even is positive, right? 1 over 2 squared. The answer is 1 over 4. Okay. Minus into minus half. So it is plus half minus 2. Now we multiply. 3 times 1 over 4. 3 over 4 plus half minus 2. Now we have, what do we have here? Unlike fraction. The denominator is 4 over 4 times 3. Okay. 4 over 2 times 1. It is 2. 4 over 1 times 2.
minus
minus 8. Okay, we can make two fractions or three fractions together. So the answer is 3 plus 2 minus 8 minus 3 over 4. Now we should calculate Dana a of 0. Substitute.
3 into
Yes.
0 to the power 2
Okay.
minus 0
Minus 0.
minus 2
Okay. Equal. 0 squared is
0
times 3.
minus 0
So 0 minus 0 minus 2. The answer is minus 2. Question number 7. We should construct a triangle RON right at R. What do we mean by right at R? So angle R will be equal to 90 degrees. This should be written such that Rn equal 3 centimeter, RO equal 5 centimeter. How can we construct a right triangle? Knowing two sides and one angle. What do we construct first? One side. We assign the angle. We draw the second side. So we will get a right triangle. So we have drawn a right triangle. A is the symmetric of O with respect to R. Who is the midpoint? R is the midpoint. And I is the symmetric of N with respect to R. Dana, who's the midpoint? I is the symmetric of N with respect to R, so R is also the midpoint, okay? First part, we should prove that OIAN is a rhombus, okay? What do you have, Dana?
Rn is equal to RR
Given?
RA is equal to RO
Yes. What? This quadrilateral becomes
parallel
a parallelogram because the diagonals bisect each other. How can you say that it is a rhombus?
but ORN is equal to 90 degrees.
It is by given right angle.
Then quadrilateral OIAN is a rhombus.
How does it become a rhombus? The diagonals are
Perpendicular.
so it is a rhombus. Now F and H are respectively the midpoints of RO and RA. C and D are 2 points on IN. We put C and D on IN such that RC is equal to RD is equal to RF. What is the nature of quadrilateral HCFD? We should justify. Okay, look at quadrilateral CFDH. Okay, first we have RC is equal to RD is, yes, given.
RF equal RH
Given, so the quadrilateral becomes parallelogram. What also we have?
RF equal RC equal to RH equal to RD.
Then and angle CRF is 90, so the quadrilateral becomes
Square.
the quadrilateral becomes a square. Okay, so we have question number 8. We should factorize the following expressions. A equal x into 2x minus 1 plus 2x minus 1. What do we have here, Dana? In the first one, what do we have?
A remarkable identity.
In the first one, we have a remarkable identity. We have a common. What is the common? 2x minus 1 is the common. If we divide the first term by 2x minus 1, we will have x. The second term plus 1. Now, Badia, the second one, b equals 16y squared minus 9. What do we have here? Which remarkable identity? A squared minus b squared. We should write it how? A. Yes. What is a of 16y squared?
4y
Yes.
minus 3
Okay.
and 4y plus 3.
Good. 4y plus 3. Now part C. Ala, C equal 4 into x minus 1 all of it squared minus 16 into 2x plus 1 all of it squared. What's this, Ala? Which is? The last one, which is what? A squared minus b squared is equal to, Ala, the rule. Into? Yes. Let's write a minus b into a plus b. What is a? 2 into x minus 1, yes. 4 2x plus 1. This is a minus b. Now a plus b, Ala.
2 into x minus 1
Yes.
minus plus 4 into 2x plus 1.
plus 4 into 2x plus 1. Okay?
2x minus 3y.
Now we work each parenthesis alone. Yes.
2x
Yes.
minus 2
Okay.
minus 8x minus 4.
Okay. The second one.
2x
Mm-hmm.
minus 2
Yes.
plus 8x plus 4.
Okay, Ala. Now let's reduce.
Minus 6x
Okay.
minus 6.
Yes.
10x
Mm-hmm.
plus 2.
10x plus 2. Can we take any common? From the first,
6.
minus 6. From the second, outside they become minus 12 into. If we divide the first by minus 6, the answer is x plus 1. The second divided by 2, the answer is 5x plus 1. Did you get this? Now part D, Muhammad. You have x squared minus 6xy plus 9y squared. What's this? Is it a remarkable identity?
Yes.
Which one?
The second one.
The second one, a squared minus 2ab plus b squared. We should write it like this. What is a?
X.
X. What is b?
3.
Just 3. B squared, Muhammad, is 9y squared. What will be? It is 3y. Why did I write minus at the middle?
Because it is on the second one.
The second one, its sign is minus, so it is minus b. Now E. Selena, 9a squared plus 12a plus 4. First remarkable identity. Yes. A is 3a plus 2. Now F. Look at F. Do we have any remarkable identity?
No.
We have similar binomials. How can we make them the same? We take a common minus. Yes, Hassan, we write x minus 2y in 3x plus y. Now minus 3. And we shift the second one.
Minus 2y.
Yes, x minus 2y. Now what's common?
X minus 2y.
X minus 2y is common.
Into 3x
Yes.
plus y.
Yes.
Minus 3.
Okay, do we have similar terms?
No.
No. Now G, Ali. What do we have in G?
We can group.
We can group. In the first two, what do you take common?
In the first one, we take common.
B into?
X minus y.
Yes.
And the second one, we take common also b.
Only B?
3b.
3B. The answer is
X minus y.
x minus y. Do we have similar terms?
Yeah, we can take common.
Which is
B. X minus y.
x minus y. Yes. Into
B plus 3b.
b plus 3b. Do we leave it like this?
No, we can
What is b plus 3b?
equal
4b. So we write it first. 4b into x minus y. Now m equal 3y squared minus 25. What's this?
A squared minus B squared.
Remarkable identity. What is the origin of 3?
Radical.
Radical 3. Yes. So we write here, Ala, what do we write? Radical 3. Yes. Right. Good, Ala. Plus 5. Now the last one, H. We have 3x into 4x squared minus 1 plus 2x plus 1. Do we have any common? What do we see? We see a remarkable identity where 4x squared minus 1. So we write 3x into. What do we write for x squared minus 1? 2. Yes, 2x minus 1 into 2x plus 1 plus.
2x.
Now what do we have common?
2x plus 1.
Bravo. 2x plus 1. Now we have 3x into
2x minus 1.
yes plus
1.
1. Now
2x plus 1.
okay
6x
equal 6x squared minus 3x plus 1. Do we have similar terms?
No.
Thank you.